Hello, my name is Keshwani. This K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 246, and today is our lesson number 159. 246, problem number 21, part C. Right here, number 21, part C. We're going to pick up from where we left off yesterday. This story is going to continue from yesterday. If you have not watched yesterday's video, make sure you watch it so that you know where we are. Here's what happened yesterday. We had a parabola. We had a parabola in a standard form. Let's put it right here at the bottom without actually erasing any of the important stuff. We started out yesterday with a simple parabola y equals x squared, and we called it the f of x. And then what happened was, I'm just giving you a recapitulation of what went on yesterday. And then what happened was, we picked it up and we shifted it to the left by 20 units. We picked it up and shifted it left 20 units. And as a result, we found yesterday that the new function that we get looks something like this. X plus 20 squared. We have to add 20 to x. That was the step number 1. Then we picked up this new function, the g of x. We picked it up and we flipped it. We flipped it upside down. And as we did that, we found that the new function that we got, which we call h of x, is negative 1 times this old function. Then we picked up this new function h of x, the one that is flipped over. We picked it up and we shifted it up along y-axis by 5 units. We shifted it up by 5 units. And we found that the new equation that we got was y equals 5 minus x plus 20 x squared. There we go. This is where we left our story yesterday. J of x, which is right here, which is where we're going to pick up our story from. What does the graph look like for J of x? It looks like exactly what it shows here. We have a parabola which is sitting at a vertex of negative 20 and a positive 5, because it's been shifted up 5 units, positive 5, because it's been shifted to the left by 20 units, x is negative 20. So that's this vertex. Instead of 0, 0, it is negative 20, positive 5. Negative 20 because it's been shifted to left by 20 units, positive 5 because it's been shifted up by 5 units. The line of symmetry is right here, where x equals negative 20. The question is, in this function, the question now is, in this function, j of x, are there any limitations as to what values x can or cannot assume? Are there any limitations as to what values x can or cannot assume? The function looks like this. In other words, what we are asking is this. In other words, are we going to have problems? Are we going to have some problems evaluating the value of this expression if x happens to be some positive number? Answer, of course, is no. X can be positive 3, and positive 3 plus 20 is going to be 23. Well, of course, we can figure out the square of 23. X can be 2, 22. Of course, we can figure out the square of 22. X could be 77. 77 plus 20 is 97. Of course, we can figure out the square of 97. Can x be a negative number? The answer, of course, is why not? X can be any negative number you want. If x happens to be negative 20, it's going to be just 0 squared. If x happens to be negative 50 and a positive 20, it's going to be negative 30 squared. Of course, we can figure out what that is. X can be negative 4, x can be negative 14, x can be any negative number. Are we going to have any trouble? Are we going to run into any problem if x happens to be a fraction, positive or negative fraction? The answer, of course, is no. X can be any fraction it wants to be. Of course, we can figure out 20 plus any fraction or 20 minus any fractions. We will have an answer here, and we can square it. No problem at all. Can x be a rational number, an irrational number, a fraction, a positive number, a negative number? The answer, of course, is yes. Now, if you don't know what a rational number, irrational number is, 1 over 3. Now, this is, I'm going by my memory, okay? So I might be wrong. It's too late in the story because I only started how to finish it. I'm going by my memory. I think a rational number is where, an irrational number is where it never ends. 1 over 3 never ends. It's just 0.33333 forever and ever. That's called irrational number. A rational number is something that does end. For example, 1/2 is just 0.5. But it doesn't matter. It doesn't matter what value x takes. We can always figure out the value of this part, x plus 20. It doesn't matter what value x takes. We can always very easily figure out what x plus 20 is, and therefore we can figure out the value of x plus 20 squared, and therefore we can figure out what is 5 minus that quantity, and therefore we can figure out the value of the function. The answer to the question in this function, are there any limitations as to what values, x can or cannot assume? The answer is no. There are no limitations. The answer is no. There are no limitations. There are no limitations as to what x can be. X can be whatever the hell it wants to be. X can be whatever the hell it wants to be. Now what we're going to do is we're going to translate this part right here, the part that is expressed in such elegant manner, and we're going to translate this into mathematical language. This is the English language. Very simple, very straightforward language. Anybody can understand it. X can assume any value that it wants to be. X can be whatever the hell it wants to be. How do mathematicians say it? Let's write the way the mathematicians write it on the top here. The mathematicians would say, translation of this thing here is, a mathematician would say, domain of this function, the function that we just erased, which was y equals 5 minus x plus 20 squared, domain of this function, I forget what we called it. I think we called it j of x, didn't we? Yeah, I believe we called it j of x. Must be j because we started with f. F was the original one. Then after f comes g, where we shifted it to the left by 20 unit, and then we picked it up and we flipped it. There must be f, g, h. That must be h. Typically, we do not use letter I to represent the name of the function. I don't know why, but we don't. It must be j because we flipped it and then we shifted it up 5 units. So this is how we say it. X can be whatever the hell it wants to be. Translation is, domain of this function is all real numbers. Voila. Domain of this function is all real numbers. That's all. That's all there is. Or better yet, they would say the domain of this function is set of all real numbers. Now it's real geeky. That's how we say it. So that was the first thing they asked us in this question. They asked us to point out the domain of the function. We just did that. Let's carry on then. I'm going to erase all of this thing. We don't need any of this. Next question is, what is the vertex of this function? The next question is, what is the vertex of this function? Well, the vertex of this function is right here. Negative 20 and 5. X is negative 20. Why is x negative 20? Because it has been shifted to the left by 20 units. Why is y positive 5? Because it has been shifted up by 5 units. And that's all. So that was the second question. The third question is, what is the line of symmetry? Line of symmetry. What is the line of symmetry of this guy? Well, line of symmetry is very simple. This is the line of symmetry. I shouldn't have plotted it like this because typically we do not put a continuous line for the. Typically, convention is that we put continuous line like this only for y and x axis, and any other lines we show it like this. That's what I should have done here. So that is your line of symmetry here. I'm going to erase it and rewrite it properly the way it should have been done in a dotted line. This is the line of symmetry. Line of symmetry is x equals negative 20. X equals negative 20 right here. X equals negative 20 in this, along this line. That's your line of symmetry. The parabola is symmetric along that line. That is your mirror. Think of this as a mirror. So whatever you see in this half here, the reflection of that is reflected in the other, in the mirror, and that's your line of symmetry. Everything is symmetric along that line where x equals negative 20. The very last question that we have to answer, what they are looking for is, what are its intercepts? Let's answer that question, shall we? Again, we can erase all of this thing. But I always put out because I need the room. I don't know why I have to say that thing, but I have that urge to say it, so I do. Even though it is bloody obvious. But bloody obvious is what I do. That's my forte. Oh, let's learn this word. We never did learn it. Let's learn the word recapitulate. A lot of you already probably know it because I have gone over it many times. And if you do not know what recapitulate means, and if you would like to improve your vocabulary along with improving your mathematical skill to get ready for the GRE, having a decent vocabulary is a must. You can watch my vocabulary videos. It may help you a little bit. Watch 3 of them and judge for yourself. Recapitulate is something that we learned on day number 32. Day number 32. Just type in my name, Keshwani. Just type in Keshwani and then type in vocabulary, day 32. Vocabulary, day 32, and you will learn this word, recapitulate. What does it mean? Recapitulate means, well, most people do not use the entire word. Most people abbreviate it and they say, let's recap it. Recapitulate means to summarize, which is what I did in the beginning of the video. I said that let's recapitulate what we did yesterday. Let's recap. Recap is not a real word. Most people do not realize it, but recap is not a word. Recap is simply an abbreviation of the word recapitulation. What does forte mean? I just used that word forte. I said that I need to erase the blackboard. I said that I need to erase the blackboard because I need more room. And then I went on to explain that even though it is bloody obvious, but I need to say it anyway, because pointing out the bloody obvious is my forte. What does it mean, forte? Forte is somebody's strong suit, somebody's strong point, somebody's strong point, a strong suit. When did we learn forte? I know we learned it. I want to find out which day we learned it. Watch this entire video, you may learn some more interesting words, some more useful word. Day number 48. Somebody's strong suit, somebody's strong point is called their forte. What do we call somebody's weak point? Somebody's weak point might be that they have this uncontrollable urge to buy shoes, and wherever they see a decent pair of shoes, she must buy it. That's her foible. Oh, sorry, that's her weak point. Or somebody's weak point might be sweets. If they see sweets, they must have them. They have sweet tooth and they cannot resist sweets or candies, and that's their weak point. They can't resist it. That's called foible. Again, on day number 48. The words forte and foible come from fencing. Forte, the strong point, is the part of the sword that is closer to the hilt. Oh boy, Jesus, this is never going to end. Do we know what hilt means? Day number 48. You see, they're all there. That's what I mean. If you watch, when I point out a word and I tell you that go and watch that video, even though, and if you know the word, you'll say, why the hell should I watch the video? I already know the word. But watch the video anyway, because you may learn some other stuff that you do not know, because I don't just cover Forte. Anything else that comes to my mind that is related to it is there. Anything else that comes to my mind. And of course, if one is talking about Forte, the natural thing would be to ask ourselves, what will be the antonym? What will be the opposite of it? The opposite will be foible. And the next question that will come to one's mind is, where do these terms come from? Well, they come from fencing. The next question that comes to one's mind is, what do Forte and foible have to do in fencing? Well, Forte is the strong point of the sword. Where is the strong point? The strong portion of the sword is the one that is closer to the hilt. Oh, what the hell is a hilt? You're going to learn all of that in the video. Do you understand? And foible, of course, is the weaker part, which is the upper half. Do you understand? Anyway, how did we get into this thing? I do not know. I do not remember what the hell we were talking about. Oh, so I need more room. Therefore, I'm going to erase it because I know I need more room. I know it's bloody obvious, but I'm going to point it out anyway, because that is what I do. That is my forte. Pointing out the bloody obvious. So, let's continue here. The last question that we have to ask ourselves, the last question, question number 4, we have to ask ourselves is, what are its intercepts? What are the intercepts of this guy? In other words, where does it cut x-axis and where does it cut y-axis? Well, x-axis it cuts right here. Well, obviously that's where the y is equal to 0. So what's the value of x? That's what we have to find out. Y, of course, is 0. But what is this guy right here? And this guy, what is the value of x when y is 0? That's what we want to find out. And where does it cut the x-axis? It's going to cut x-axis somewhere way down there. Remember, this is sitting at 20. This is sitting at... Let me redraw this thing. I'm going to erase this whole thing. Well, let me do it here. This is what's going on. You see, there is your y-axis, there is your x-axis, and this guy is sitting at x equal to 20. It is sitting at x equals to negative 20. And it's sitting like this. Okay, watch what happens. It's sitting like this. Somewhere down here it's going to cut the x-axis. Somewhere way down there, not this close, but way down there, it's going to cut the x-axis. We want to find out the value of this guy. When it cuts the x-axis, that's where this is your y-axis, that's where y is equal to 0. We want to find out what is the value of x. What's the value of x? And we want to find out this. This is where y is equal to 0. What's the value of x? What the hell? This is where it cuts the x-axis. So y is equal to 0. Y is not 0 here. It's the x. This is the y-axis. This is the y-axis. That means x is 0. And the question is, what's the y-intercept? Here x is here. Y is 0. We want to find out what's the value of x. Similarly here, what's the value of x when y is 0? So this portion here, the y-axis that you see here, the y-axis that you see here, and the y-intercept that you see there, is not shown here because this is x equals to negative 20. It's way over there somewhere. So let's do it. X intercept is where the graph cuts x-axis, which is why it's called X intercept. That's where y is equal to 0. Okay. Now don't be anal. Don't worry about the fact that I just started a new sentence with a small letter. It doesn't really matter. That T must be capital. It doesn't really matter. So that's where y is equal to 0. Well, y is this. Y equals 5 minus x plus 20 squared. And we know that in order to find the y-intercept, in order to find the x-intercept, the y has to equal to 0. So we take that quantity and equate it to 0. And we just solve for x. So let's do that. So y equals to 0, where it cuts the x-axis. Let's subtract 5 from both sides. In other words, I'm not going to explain everything. This is what's going to end up. X plus 20 squared. X plus 20 squared equals 5. I know you can figure it out on your own. Therefore, x plus 20 would equal plus or minus square root of 5. Plus or minus the square root of 5. For example, if we are told that a squared equals 9, therefore a would equal plus or minus square root of 9. In other words, if a squared equals 9, then a would equal plus 3 or negative 3. Negative 3 squared gives us 9, and positive 3 squared gives us 9. Therefore, if a squared were to be 9, a would be positive or negative square root of 9. That's exactly what's going on here. Here, this quantity squared equals 5. Therefore, this quantity itself must equal positive or negative of the root of this number, root of 5. And therefore, it implies that x equals to negative 20 plus or minus root 5. Voila. There we go. We're going to evaluate this quantity and we're going to point it out, and we'll be done with the x-intercept, and then we'll find the y-intercept. Let's carry on then. Let's carry on. What is the square root of 5? What is the square root of 5? Now that may seem like a silly question to you, for me to ask, but there are 3 square roots that you should know by heart for the exam. They come in quite handy. Let's start with the very first one. You must know square root of 3. Sorry. You must know square root of 2. You must know square root of 3, and you must know square root of 5. They come in very handy for the exam. Let's start with square root of 2. Okay. Watch what happens. I'm going to put this away someplace so that I have the room here. Where can I put it? Put it away. Let's put it here. X equals negative 20 plus or minus root 5. Let's start with the square root of 2. In order to find out the square root of 2 and 3, you must know your squares 1 through 20. Of course, I know that you know your squares 1 through 10. I know you know your squares 1 through 10. We're going to quickly go over it. We will quickly go over them, you and I together. So here we go. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Of course you know them. Question is, do you know your squares from 11 through 20? And if you don't know them, you must know them for the exam. They come in quite handy. Don't tell me what's the bloody point. I have the calculator in the exam. The calculator is there. Calculator is not a crutch. It's a tool. Don't depend too much on it. You must know your square. 11 square is 121. 12 square is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. You must know these by heart. What about 17? Let's find out 17 squared. 7 times 7 is 49. 7 times 7 is 49. 9 carry 4. 7 plus 4 is 11. And then 17. So you get 9, 289. As you can see, even I did not know 17 squared. It's not something that appears very often in the exam. The only reason you need to know the square of 17 is because we need to figure out this part, and you will see the connection in a second, okay? Just be patient. 18 and 19, don't worry about it. You should know your 20 squared. 20 squared is 400. 18 and 19, don't worry about it. And then 20 squared is 400. Now, let's see 14. 14 is, this is this. 14 times 14 is, 4 times 4 is 60. 4 fours are 16. 6 carry 1. 4 and 1, 5. And then 4 and 1. 6, 9 and 1. As you can see, 196 right here. Now watch what happens. Watch what happens. If 14 times 14 is 196, then 1.4 times 1.4 must equal 1.96. You just take your decimal place and move 2 places. 1.96. What that tells us is that square root of 1.96 equals exactly 1.4. And therefore, the square root of 2 approximately equals 1.4. Voila. You have to know that. And You don't have to do anything, you just have to know your square. Square of 14 is 196. You should know that offhand. Do you understand? Similarly, let's do one for 3. We just found out here 17. We just did a little while ago, didn't we? 17 times 17. We just did 17 times 17. We just did it and we found out that it is 289. 289. Therefore, 1.7 times 1.7 must equal 2.89. What that tells us is that square root of 2.89 equals 1.7. Therefore, the square root of 3 approximately equals 1.7. So that's the square root of 2, that's the square root of 3. Now we'll do 5. Let's do 5. So square root, again, 17 times 17 is 289, therefore 1.7 times 1.7 must be 2.89, which is approximately equal to 3. Therefore we can say that the square root of 3 is 1.7. Let's do 5. The same logic will apply for 5. When you see 5, think of 500. Well, 500 is somewhere between 400 and 625. And you will see in a second where I'm coming from with 400 and 625. 400 is the square root of 20. And 625 is the square of 25. You should know these things. If you don't, if I'm throwing something casually, that is an implication that implies that I take it for granted that you either know it, or if you don't know it, you will memorize it. You should know square of 25. There is no reason, there is absolutely no reason whatsoever for anybody to be sitting there in front of the computers ready to take the real GRE, and when you approach them and you ask them what is the square of 25, and they would say, I don't know, let me use the calculator. That is not a good sign. That is not a sign of a person who is about to get a decent score. Do you understand? There are some basic things that you must have at your fingertips, and that is just the way it is. There are certain things that you're expected to know. So square of 25 is 625. The square of 400, the square of 20 is 400. The square of 25 is 625. Therefore 500 falls somewhere in between. That tells us that the square root of 500 must fall somewhere between 20 and 25. It must fall somewhere between 20 and 25. Let's put it here. This is your 20, this is your 25, and my gut feeling is that it's not going to be 24, because 24 is going to be square of 24, it's going to be something close to 600, it's going to be in the high 500. My gut feeling is that if you go to square 24, it's going to be in the high 500. Similarly, my gut feeling tells me that the square of 21 is going to be closer to 400. It's not going to go all the way to 500. Because we're going from 400 to 625. Which means we only have to try 22 and 23. We only have to try 22 and 23. It's going to be either this or that. We're going to try out both of them and see which one comes closer. Okay? We're going to try both of them and see which one comes closer. Let's do 22 first. 22 times 22. 22 times 22 is 44. And another 44. 484. You see 484, that's very close to 500. Let's do 23. 23 times 3. 23 times 3. I know 20 times 3 is 60. Therefore 23 times 3 should be 69. So that's 9 carry 6. And then 23 times 2. 23 times 2 is 46. 46 plus 6 is going to be 52. So which one do you suppose is closer to 500? Which one do you suppose is closer to 500? This guy or this guy? Well, this guy, if you look at this guy is 29 off from 500. It's 29 away from 500, and this guy is only 16 away from 500. It's only 16 away from the 500. So it'll be closer and it'll be more proper. It'll be the approximation is going to be better if you were to say that 22 times 22 is approximately 500. We're going to make a note of it. We're going to make a note here that 22 times 22 times 22 is approximately 500. Therefore 22 times 2.2 times 2.2 must be approximately 5. Must be approximately 5. In other words, the square root of 5 is approximately 2.2. Is approximately 2.2. That's it. I'm going to erase all of this now. I'm going to put down the answer underneath them and memorize them. Okay? Take advantage of this thing. Don't. Sometimes my videos are very long. This video is going to be very long. But you're not going to find tutors who will take this much time to explain things in this much depth. Nobody has that kind of patience. Take advantage of it. Square root of 2 we just found out is approximately 1.4. Why is it approximately 1.4? Because 14 times 14 is 196, which means 1.4 times 1.4 is going to be 1.96, which is very close to 2. The square root of 3 is approximately 1.7. Why is it 1.7? Because 17 times 17 we found out was something very close to 3. I don't remember it now. 289 I think it was. And 289, which is same as 2.89, which is very close to 3. Square root of 5 is approximately 2.2. Why is it 2.2? Because we just found out that 22 times 22 is 486, I believe it was. Can it be 486? Ask me that question. Tell me that answer. 22 times 20, I said was 486. Was that a silly thing to say? Yes, of course, that was a very, very silly thing to say. That was a very idiotic thing for me to say. Because 22 times 22, I don't know what the hell it is, but it cannot be 486. Why not? Because the unit digit has to be 2 times 2, which is 4. It must have been 484. And 484, of course, is very close to 5. Therefore, square root of 5 is approximately 2.2. We're going to use that information here. So, our X intercepts are these. Our X intercepts are negative 20 plus or minus root 5, which means it's negative 20 minus 2.2 or negative 20 plus 2.2, plus or minus. Negative 20 minus the 2.2 is going to be negative 22.2, and negative 20 and a positive 2, negative 20 and positive 2 would have been negative 18, but it's not 2, it's 2.2, so it's going to be negative 17.8. Well, that's it. We are almost done. See this question mark here? See this question mark right here? We have to replace this question mark and put a number here for the intercept. Negative 17.8. Negative 17.8 and 0. And this guy is negative 22.2. Negative 22.2 and y is 0. So those are your x-intercept. We found the y-intercept, which was way down there someplace. I forget what it was. This is your vertex. The line of symmetry is x equals to negative 20, and you know where the graph comes from because we learned that yesterday. Now we have done the justice to this problem in terms of understanding what is behind it. Alright? I'll see you tomorrow. Bye now.